Hello and welcome to Chapter 8, Section 5. We're working on factoring special products today. And what we want to be able to do is recognize trinomials. A trinomial is a polynomial with three terms. A perfect square trinomial is what you find when the first and the last numbers are perfect squares. The middle term is going to be 2 times the square root of a times the square root of b. So let me show you. The square root of 9 is 3. The square root of 4 is 2. So 2 times 3 times 4 is going to be 12. We are looking for this number. So when we find perfect square trinomials, the question they're going to ask you is this one? You want to look at these two numbers. Is 9 a perfect square? Is 9x squared a perfect square? Yes, because it's 3x times 3x. Is 4 a perfect square? Yes, it's 2 times 2. And is the plus 12x in the middle going to work with that? Well, we want to say 2 times 3x times 2. 2 times 3 is 6, times 2 is 12x. So if we did FOIL on 3x plus 2 squared, we would end up with 9x squared plus 12x plus 4. And like always, you're going to go back and check them. You're going to do your FOIL. 3x times 3x is 9x squared. And first and outside and inside and last, and that's going to give you this, and you're going to combine these to get 12x. So can you recognize a perfect square trinomial? And these are the rules. Square root of this, square root of this, times 2 should equal that. So let's practice that a few times. The question is, are these perfect squares? If they are, factor. And if they're not, explain why they're not. Now, we just did something very similar to this, so that's okay. We have to make sure that we understand that we are adding together two negative numbers this time. So we're going to have a subtraction sign in there, and that one's going to be an x. So we're looking for the square root of this. Square root of 4x squared is 2x. Square root of 9 is 3. And does 2x times 3 times 2 equal, whoops, and that's a negative 3, equal negative 12x? Yes, it does. So this, our answer is yes. Is it a perfect square? Yes. And here it is. We've factored it. And we've proven it. Let's do another one. X squared plus 9x plus 16. Well, x squared is a perfect square. That's x. And 16 is a perfect square. That's 4. Both of these are positive, so this is a plus sign. So now the question is, x plus 4 times x plus 4, does that give us 9x in the middle? So square root of 1x squared is just x. And the square root of 16 is 4. Whoops, multiply. And we're going to multiply that by 2, and we've got 2 times 4 is 8, times 1x is 8x. And that's not the case here, so this answer is no. And we want to say because this equals 8x. Or it doesn't equal 9x. You get to say whichever one you want, okay? Give this a shot. Have a look at checkpoint questions number 1 and see how these go for you. There's 3 of them there on the top-ish of page 579. Pause here and come back when you're done. So we have 3 questions here. The first one, x squared plus 4x plus 4. And we come up with x plus 2 squared, and yes, because 2 times 1 times 2 is 4, and so that works. And that's got an x, and that's got an x, so yes, that works. Here we have 2 times 1x times 7 equals 14. And because this is a negative number, they're going to equal negative 14. 2 times. So this answer is yes because of that. For 1C, we have 2 times, square root of this is 3x, square root of that is 2. 2 times 3 times 2 is 12, not 6. So the answer here is no. This is not a perfect square trinomial. Example 2 shows us word problems, and it gives us a park in the center of the Place de Volcher in Paris, France. Is in the shape of a square. Now we know a square has all equal sides. And the area of the park is this. So we want this to be a perfect square because in a square, this, whatever it is, it has to be the same as this. So we can say squared, which means this times this. Which means this can't be a rectangle, has to just be a square. So we want to find whatever the side is. So it's something x plus or minus, it's going to be plus something. Okay? And they have to be whole numbers because it says C and D are whole numbers. So we're not going to have fractions or decimals or anything. So the first part of the question says, find an expression in terms of x for the perimeter of the park. In terms of x for the perimeter. Now, perimeter means we're going to add up all the sides. So it's going to be 4 times whatever the side is. And we have to figure out the side by understanding that this is a perfect square trinomial. We have to figure out the side. And then we have to find the perimeter when x equals 8. So we have to find this perfect square trinomial factor first. So we've got 5x here. We've got 7 here. It's going to be positive. So 5x times 7 times 2, 35 times 2 is 70. And that number, oops, x, are the same. So we know that we got it right. We've checked our answer. So the perimeter of this is going to be 4 times this, 5x plus 7. Now what I have to do is when x equals 8, find the perimeter. So we have to plug an 8 in here and do our math. 5 times 8 is 40, plus 7 is 47. Times 4. Okay? You've got your very own checkpoint number 2 question in the middle of page 580. Please pause here, try that to make sure you can get through the homework, and come back when you're done. So for checkpoint number 2, we were given this as our perfect square trinomial, and 2 times 3x times 1 equals 6x, so we've got the numbers right, which means when we find the perimeter, it's going to be 4 times our square root, which is 3x plus 1. So our perimeter is 12x plus 4 meters in terms of x, and when x equals 3, our perimeter is 40 meters. How'd you do? The second thing I'm asking you about is the difference of 2 squares. And that's when a squared minus b squared factors to a plus b times a minus b. There's only 2 terms in this, and one of them is negative. Both of them are perfect squares. This term is a perfect square, and this term is a perfect square. And what we need to do is realize that when we do FOIL on this, a times a is a squared, and a times negative b is negative ab, and b times a is positive ab, and positive b times negative b is negative b squared. And we notice that these two cancel each other out. So when we do a plus b times a minus b, we don't have a middle number because it's 0. And we end up just with a squared minus b squared. So the difference of two squares, the difference, meaning a subtraction problem, of two square numbers, so we could have 9x squared minus 4. And that would factor into 3x plus 2 times 3x minus 2, because we have our pattern. So if we recognize the difference of two squares, we can jump right to the answer to the pattern. Make sense? Let's give it a try. So the question is are these three problems, are they the difference of squares? If they are, factor, and if they're not, explain. So that's two answers, a yes or a no, and either factoring or explaining. So we're looking to see, yes, it's a difference, and are these both squares? Yes. So this will factor into x plus 9 and x minus 9. So this answer is yes. 9p4 is a square, 16q2 is a square, and it's a difference. So this is a yes as well. So we have a 3p2 plus 4q and a 3p2 minus 4q. X to the 6th minus 7y squared. It is a difference. This is a square. This is x third times x to the third. But this is not. So this answer is no, because 7 is not a square number. Make sense? So pause here, try checkpoint number 3 on the bottom-ish of page 581 and come back when you're done. For section 3, we have 1 minus 4x squared, and yes, this is a perfect square. 1 is 1's square root, and 4x squared square root is 2x. So we've got a plus and a minus. P squared and 49q to the 6th, yes, that is also a perfect square. 16x squared has a square root of 4x, but 4y to the 5th is not, because y to the 5th doesn't have a nice happy square root. So this answer is no. All right. Your homework tonight is page 582, numbers 15 to 39, every third number, plus you're going to do 40 to 42, all of them, and number 46. Okay? Let me know if you have any questions, and I'll see you tomorrow.